Hi guys, I'm Mohan Desai, studying in Vishnu Institute of Technology in branch Artificial Intelligence and Data Science. In this video, I'm going to explain about cabinets partitioning problem. So first we observe the description given by the question. Now I'll explain about the question. Here we are given n task where each task has a fixed amount of time. We are we also have k workers. Each worker can do only one task at a time, cannot be split, and each worker must take continuous tasks only. So here our goal is to minimize the maximum time taken by any worker. So we have to find minimum possible time so that all tasks are completed. So to achieve this, we can go with three approaches. Those approaches are brute force, dynamic programming, and binary search. The first approach is brute force, where we try all possible ways to divide the task into k contiguous parts and calculate the maximum workload for each partition. However, the number of such partitions grows exponentially with n. As you can see in this code, the time complexity becomes big O of 2 power n, which is not feasible for large inputs. So we will not go with brute force. Now let's try with the dynamic programming. The second approach is dynamic programming. We define dp of I, j as the minimum time required to complete the first I task using j workers. To compute this, we try all possible split points, which results in three nested loops. Here you can see as I said. So the time complexity becomes big O of n square into k, which still exceeds the constraints given in the question. So we go with binary search on answer. So it is optimal. Like I said, the optimal approach is binary search on the answer. Since the answer lies between the maximum task time and total sum of tasks, we apply binary search this range. For a given mid value, we check if it is possible to assign tasks using at most k workers such that no worker exceeds mid time. This feasibility is done gradually by assigning tasks in order and continuing workers. We apply binary search on this range. Like for each mid value, we greedily check if tasks can be completed using at most k workers without exceeding mid time, so that the time complexity becomes big O of and log sum. The binary search runs in log of the sum of tasks, and for each step, we perform a linear feasibility check. So that's why it's optimal. And now my friend will continue.
Hi guys, now let's see the Java implementation of this problem using binary search, which is an effective approach for solving without violating constraints. As Mohan said, this problem is about distributing tasks among workers in an optimal way. The goal is to minimize the maximum time taken by any worker while ensuring tasks are assigned in continuous order. We can observe that the total time to finish the job is decided by the slowest worker. Trying all possible ways to decide the task would be exponential and inefficient. So we use optimal one, that is using binary search. Instead of deciding which worker gets which task, I decide the maximum allowed time for a worker and check if the job can be completed or not in that time, which turns the problem into a decision problem. Now, in what range should we do the binary search? The minimum possible time is the largest single task because someone must do the task. So here it is 23. And what is the maximum possible time to complete the job? It is the sum of all tasks. So the answer lies in this range. Now we'll write a code. Now we'll take two variables. In low is equal to 0, int high is equal to 0. So here low represents the minimum possible value, right? And high represents the maximum possible value. So to assign the minimum possible and maximum possible, we'll take it for each loop. And for every element in tasks. O is maximum of the array, right? Maximum of I comma low, and high plus equal to I. Okay. Now let's assign answer is equal to high. We'll comment out this. And after assigning answer is equal to high, we'll write the binary search logic. While low less than or equal to high, because low should not increase more than high, take a mid value. Mid is equal to low plus high by 2. And I take mid value as the candidate time, and if the task can be completed within this time, I try to reduce it further by making high equal to mid minus 1, and otherwise I increase the allowed time. So I'll write a function with name can finish, which I'll write in after writing the logic of binary search. Tasks, comma, workers, comma, mid. Now, if it is feasible, answer is equal to mid, and I try to reduce it further, so high equal to mid minus 1, and else low is equal to mid plus 1. Return the answer. So now to check if the candidate can complete the job at the mid value, we'll write a Boolean function. Private Boolean. So we thought of keeping can finish, right? Can finish and tasks, comma workers. Sorry. And max time. Okay. This function checks the feasibility. So I assign tasks in order to current worker. So I'll take two variables. Used worker, that is equal to 1, because at least we need one worker, right? Shit. Okay. And then current sum is equal to 0. If adding a task exceed the allowed maximum time, I assign it to a new worker. And if number of workers used exceeds the available workers, then this maximum time is not feasible. So for int I in tasks, if of current sum plus I less than or equal to max time will increment the current sum. Current sum plus is equal to I. Else we need another worker, right? So workers plus plus. And current sum need to be the value where particular condition in if loop breaks. So current sum is equal to I. Return used worker if less than or equal to workers. So now we'll try to run this code. Yeah. Now let's visualize the code with an example. Let's consider an array 10, 20, 30, 40. These are the task times and number of workers k is equal to 2. By observation, we can say that minimum we can think of is 40 and the maximum is total sum, which is 10 plus 20 plus 30 plus 40, that is equal to 100. So the answer lies in between 40 and 100. If we take shortest maximum time to complete is equal to 50, our function checks the feasibility. So let's think if the array is splitted like 10, 20 and 30, 40. So the first worker does the two tasks 10, 20 so in 30 seconds. And worker 2 completes the remaining tasks in 30, 40, that is equal to 70 seconds. So it exceeds the maximum possible time, so not feasible at this split of tasks. It means we need another worker, right? So, but actually we got only two workers. So if we take shortest maximum time to complete is equal to 60, and if the split is 10, 20, 30 for one worker and 40 for other, checking feasibility. Worker 1 completes the tasks in 60 seconds and worker 2 completes the task in 40 seconds. So feasible returns the 60 as answer. This is the minimum possible for this array. So coming for time and space complexities, the binary search runs in log of sum of tasks iterations. Each feasibility checks of n time. So the overall time complexity is of n log s, where s is the sum of tasks, and the space complexity is O of 1 since only variables are used. So to conclude this video, among all approaches mentioned by the Mohan, this is the efficient, scalable, and works well even for large inputs. It combines greedy strategy with binary search on the answer. Thank you.